Need help with GED math word problems? Then you're in the right place. Hi, this is Parker from Test Prep Champions, teaching you how to pass the GED fast. You can get started by clicking subscribe down below. So in this video, I'm going to walk you through some word problem examples, and these are multi-step word problem examples that help you understand how to do word problems and how to beat the common types of questions you'll get on the GED test. So let's get started. So question number 1 is Jason's weekly salary was $746. Jason decides to work part-time instead, and now his weekly salary will be $535. By what percent did his salary decrease? So pause the video now and try to solve this question, and then we'll go over how to do it. Okay, let's go over how to do this question. So this is what we call a percent of change question. And what we want to find here again is by what percent did his salary decrease? So for these percent of change questions, all right, the steps will be a little bit different per question, but the basic idea is that at first we want to find the amount of change here. So first we want to find the change in Jason's salary. So we want to find the change in Jason's salary. And so how do we do that? Well, what we want to do is look at his starting amount, which was $746, and the amount that he will be making, which is $535. So let's say the change amount, or the amount of change, however you want to look at it, is AMT. So AMT, I'm just going to abbreviate amount. So the change amount is 746 minus 535. And so again, we're looking at the amount of change here, and we're looking at what his salary was originally, and we're going to subtract what his salary is going to be. And so if we do the math here, 746 minus 535 is equal to 211. So the amount of change is $211. All right, and so now the second step is that we want to make a fraction here. So we want to write a fraction with the change over the starting amount. So the second step is to make a fraction. And again, what kind of fraction? Well, we're going to take the amount of change here, which is 211. And so we take that 211 and we want to write it over the starting amount, all right, or his starting salary. So his starting salary was 746. So we look at the change amount, which is 211, and we write that over 746. So we have our fraction. And so now the third step is we just want to express this fraction as a percent. All right, so step 3 is to express the fraction as a percent. So whenever you have a fraction, all you have to do is just take the top number and divide it by the bottom number, and that's going to give you the decimal. So in your calculator, you can do 211 divided by 746, and that's going to give you about 0.28 here. So you should get 0.28. All right, so now we want to express this as a percent. So if you've been studying for a little while, you might automatically see that 0.28 is equal to 28%. All right, and that would be the correct answer. But if you didn't see how to take that decimal and turn it right into a percent, then let me give you a tip here. So to change a percent to a decimal, to convert a decimal to a percent, you want to move the decimal to the right 2 places. All right, so you want to move the decimal, and the decimal is just this little dot right here. It looks like a period, but it's a decimal. So you want to move the decimal to the right 2 places. So move decimal right 2 places. So all we would do is we see this 0.28. All right, so you move it to the right 2 places, and then you just turn it into a percent. All right, so we have this 0.28 here. So we want to move the decimal 2 places and then turn it into the percent. So we go 1, we go 2, so this is where our percent sign is going to go. All right, so 0.28 is equal to 28%. Okay, so let's just look at another mini example of this. And so what about if I give you the decimal 0.04 and I say, I want you to express this decimal as a percent. So all you have to do is you just take this decimal and you move it to the right 2 places. So we go once, we go twice. So right here is where our percent's going to go. So 0.04 is equal to 4%. Okay, and in some cases you might even need to add zeros in. So let's say that you've got this. Let me give you this little example here. So let's say we have 0.4 and I say express this as a percent. So again, you move the decimal to the right 2 places, but we don't see 2 places here, so we've got to add some zeros in here. So we go once, we go twice, and so right here is where our percent sign is going to go. All right, so we would write 4, keep that 0, and then right here is where a percent would go. And so once you get the hang of it, you'll be able to just look at a number like this, 0.28, and just think, oh, that's 28%. But until you get the hang of that, just remember, you move the decimal to the right 2 places and then add the percent sign right there. Question number 2. Jake's wife, Amy, earned $17 more than triple Jake's pay last month. In total, Jake and Amy earned $3,112 last month. How much did Jake earn last month? So pause the video, give this one a try, then we'll go over how to do it. Okay, hopefully you had a chance to try this out, so let's go over how to do this. So with word problems like this, first you want to zero in on what you have to find. So what do we need to find here? What we need to find is Jake's earnings. So we need to find Jake's earnings. So at the end of the question, we're going to go back and make sure that we have found this. So we're going to find, let me just put a $sign here and a J. So we're going to find Jake's earnings. So by $J, I mean Jake's earnings. So at the end of the question, again, we're going to check and make sure that we found it. All right, so what information are we given here? Well, we're told that we've got Jake and we've got Amy, and we know that Amy earned $17 more than triple Jake's pay. So from the information that we're given here, we can write some equations. So first of all, what we see here is in total. So in total, that is a keyword that suggests addition here. So it says in total, Jake and Amy earned over $3,000. So we have J plus A, right? And so by J, I mean Jake's earnings, and A, I mean Amy's earnings. So I'm not even going to write the $signs in anymore here, just so we don't clutter this up. But we can write one equation here. So this equation is J plus A equals 3,112. And again, I'm not going to put the $signs in our work here. All right, and so there's a second equation that we can write too. And that comes from the first sentence here, where we see that Amy earned $17 more than triple Jake's pay. So how can we make an equation for that? Well, let's look at the amount Amy earned. So by A, again, I just mean the amount that Amy earned. And so we know that it was $17 more. So 17 more tells us that we have to add. And it's 17 more than triple Jake's pay. So we now have two equations. And so what we can do is we want to plug one equation into the other equation. And so if that sounds a little bit complex, then just stick with me here, because this is going to make a lot of sense here. So ultimately what we want to find is Jake, right? We want to find J, because that's the amount that Jake earned last month. So the trick here is we want to use the equation that's already solved for A. So this equation too is solved for A. And by solved for A, what I mean is that on the left-hand side of the equation, A is by itself here. So this equation is solved for A. And so then we want to substitute this value in here, right? So we want to take the second equation, which is A equals 17 plus 3J. And we want to substitute that into the first equation for A. So this part here, 17 plus 3J, since we know that that's equal to A, we can take our first equation and we're going to replace the A in the first equation with 17 plus 3J. And so this is going to give us just one variable, because in this scenario here, we've got two variables. We've got J and we've got A. So we now, if we do this right, we're going to have J plus 17 plus 3J. And that's equal to 3,112. And so now, again, the strategy is to solve for J. So we can combine like terms. So we see that we've got J and we've got 3J. So what's J plus 3J? Well, think about this J as if it's 1. So 1J plus 3J gives us 4J. And we'll have the 17 here, but we can subtract 17 from both sides of our equation. So let's do that. So we subtract 17 from both sides of the equation, and we're left with 4J equals 3,095. And so we have 4j equals 3095. So this 4j is 4 times j. So what we want to do here is we want to do division because we've got 4 times j. We want to solve the equation for j. So in other words, we want to get j by itself on one side of the equation here. And so we have to undo this multiplication. So we do that by dividing, because the opposite of multiplication is division. Whatever you do to one side, you must also do it to the other. So we divide by 4 on both sides of our equation here. And so what are we left with? Well, we're left with j, and that's equal to 700, or that's equal to 773.75. So $773.75. And that is Jake's earnings. So what did we initially want to find? We wanted to find Jake's earnings, or the amount that Jake earned last month, and our value here is 773.75. That makes sense, that can work, and so we are done. Okay, question number 3. Richard's rectangular yard is 8 meters longer than it is wide. If the total length of the fence around his property is 116 meters, what is the width and length of the yard? Pause the video, give this a try, then we'll go over how to do it. Okay, so let's go over this question here. So first of all, what do we want to find here? So as always with word problems, it's always best to make sure that you seek clarity on what you want to find here. Don't jump into solving the question until you've clarified this. So in this case, we want to find the width and the length of his yard. So what we need to find is the width and the length. And so at the end of the question, we're going to check and make sure that we actually found the right answer here, and that our answers, the width and the length, match what we wanted to find here. So I'm going to write width with a W and length with a cursive L here. So hopefully you remember what a rectangle looks like, but if not, let me just sketch one out here. So with a rectangle, you've got 4 sides, and the opposite sides are the same. So this little side over here is the width, and so the width is going to be the same as the opposite side. So what I mean by that, same with the length. So this whole side is the length, and so the opposite side is the same. So the opposite side is also the length. So we've got 4 sides. We've got 2 sides that are the width, 2 sides that are the length. And so now we want to find what both the length and the width are. And what we know here is that the total fence around his property is 116 meters. And so that's the total length. And so this word total length here, that is our clue that what we're talking about here is the perimeter. So this whole area in here is his yard, say. This whole entire, everything within the rectangle, which I'm not going to trace the whole rectangle in, but just imagine that this is his property. Maybe his house is here, his shed, his garage, whatever. It's all included in the rectangle. And this whole rectangle is like a big fence around his property or his yard. And so we know that the length around this whole thing is 116 meters. So how do we find the perimeter of a rectangle? Well, the perimeter is found just by adding up all of the sides. So if we just take the width and we add, so we would do W plus W plus L plus L. So width plus length, because we're adding up all of the sides here. That's one way to get the perimeter. So the other formula, which is really the same thing, it's just a different way to write it. Since there's 2 W's, we could just write 2W plus 2L. And so however you want to do it, if you want to do it in your calculator, 2 times W plus 2 times L, or if you want to just do W plus L in your calculator, both of these formulas for perimeter will give you the same exact answer here. And so we know that in this case, the perimeter is 116 meters. So we're told what the perimeter is equal to. So P equals 116, and we're not going to write the meters for right now. So we also are told, so we know here, right, that W plus L equals 116. So let's just use the second equation since it's a little bit faster. So we've got perimeter equal to 116. And now we also know that the rectangular yard is 8 meters longer than it is wide. So we don't know what the width is, we don't know what the length is. So, but we do know that the yard is 8 meters longer than it is wide. So we can make an equation here for the length, right? So the length is what? It's 8 meters longer than the width. So we can say that the length is equal to 8 plus W. So we now have 2 equations here. So our first equation is the perimeter. It's P equals 2W plus 2L equals 116. And we now have our second equation, which is down here, which is the length equals 8 plus w. And so in this case, what we want to do is we just want to take this from the second equation. So this L equals 8 plus w, and we're going to go into the first equation here, and we're going to substitute this 8 plus w into the first equation for L. So if we do this, what are we going to have? So let me draw an arrow here and let me show the work here. So we would say that 116 is equal to 2w, so that's not going to change. 2w plus 2 times L, and so we know that since the length is equal to 8 plus w, we're going to plug our 8 plus w in for L. And so now we are down to a single variable here. So we're now down to w. So any number that's unknown, we call it a variable. So w is a variable, L is a variable, and so we want to get down to just one variable. And in this equation here, we've just got one variable. So now since we have 2 times 8 plus w, we're going to do what's called distributing. So we're going to distribute this 2. So we're going to do 2 times 8, which will be 16, and 2 times w, which is going to be just 2w. So now we can rewrite this. So we have 116 is equal to 2w plus 16 plus another 2w. All right, so we can simplify this even further by combining like terms. So we've got 2w and we've got 2w. Add that together, it gives us 4w. So let's rewrite this whole entire thing. So we now have 116, and that's equal to what? It's equal to 4w plus 16. And so again, we're trying to solve for the width here. And then once we get the width, we can find the length. So we want to get w alone by itself on the right-hand side of the equation. So in other words, we're trying to solve for w here. So we want to undo this 16. So we want to clear the 16 out. So we've got plus 16, so we do minus 16, and whatever you do to one side, you also do to the other. So we could rewrite this then as 100 is equal to 4w. So 100 is equal to 4w. And that's because 116 minus 16 is equal to 100. So now we want to get w by itself. So we've got 4 times w. We want to divide both sides by 4. And so this goes away, and 100 divided by 4 is 25. So 25 equals w. So we found our width. So the width is equal to 25. Now what about the length? Well, remember that the length is equal to 8 plus w. So 8 plus w. So what is 25 plus 8? 25 plus 8. Well, you could do that on your hands if you wanted to, or you could do it in your calculator. But if you do, we know that the length, again, is equal to 8 plus w. So 8 plus 25, because we just found that 25 is w. And so that comes out as 33. So you can use your calculator, just do it on the paper or do it in your head, however you want to do it. But we find that 25 equals the width and the length is 33, and those are the answers for question 3. And so we go back to what we wanted to find. We see that we've checked that off, we got the width and the length, and we're officially done. Now on to question 4. Anne drives west at an average speed of 45 miles per hour. Beth drives south at an average speed of 55 miles per hour. After both women have driven for 2 hours, how far apart are they? So you know the drill by now. Pause the video, try this out, and then we'll go over how to do it. All right, let's go over how to do this question. So first of all, what we want to find is their distance. So how far apart are they? So that tells us that we want to find a distance. So just by knowing that, so I'm just going to write F this time instead of writing out 5. So we want to find D. So I'm going to write D for distance. So whenever you are dealing with distance in a question, you want to think of the distance formula. So the distance formula that you'll want to know for your test, D equals RT. D, of course, stands for distance, R stands for rate, and T stands for time. Now, I've got a whole other video where I break down the distance formula more in depth, but just for now, know that D equals rate times time. So whenever you think of distance, think about this distance formula, because there's a good chance that you'll have to use it at some point in the question. And so now we also want to be aware of the paths that they're both taking here, right? Because we know that Anne is driving west. So let's kind of map out Anne's path here. So Anne is driving west, and so starting here, so let's say that this is her starting point and she goes west, which would be this direction. And then what happens? So Beth, if she starts at the same point, Beth is then going to go south. So what is being created here? What are we forming here? Well, hopefully you see that we're forming a 90-degree angle here. So this actually makes a right triangle. So we've got a right triangle here in this question. All right, so we've got we've got Anne going one way, going west, and we've got the other one, or we've got Anne going west, we've got Beth going south. And so we want to know how far apart they are. So this part of the triangle here, which is called the hypotenuse, is actually their distance apart. So in a right triangle, you're going to have this little box thing in the corner, and that is a 90-degree angle. So in a right triangle, you've got a 90-degree angle. And so the side across from your box or your 90-degree angle is what we call the hypotenuse, and it is the biggest side of your triangle here. So for any right triangle, we can write this relationship here. The relationship is side A squared plus B squared equals C squared. Okay, so this holds true for any right triangle. So let me just draw right triangle down here, and so that you can see here. So we can call this side, let's say, a side A. We can call this side of the triangle side B. This didn't close up right. There we go. And then this side of the triangle is side C. Let's say, so the biggest side of the triangle is always your side C. So A squared plus B squared equals C squared. And so in this case, the distance is going to be C. So this big side of the triangle is their distance. However, we don't know the distance Anne traveled, and we don't know the distance that Beth traveled yet. So before we can use this formula here, A squared plus B squared equals C squared, to find the biggest side of the path of the distance between them, right? Or in the triangle, it's the biggest side of the triangle. In order to do that, we need the distance Anne traveled, and we need the distance that Beth traveled. So that's where our distance formula is going to come in. So let me write an A for Anne, and I'm going to put a little D here for distance. So this is Anne's, or let me do it this way. So this is Anne's distance. So AD is Anne's distance. And so the distance formula is rate times time. So this 45 miles per hour is a rate. So Anne's distance is going to be 45, and that's the rate. And so what about the time? Well, we're told that she traveled for 2 hours, so we've got 45 times 2. So what's 45 times 2? Well, if you put that in your calculator, you'll see that 45 times 2 is 90. And that's a good one just to memorize, that 45 times 2 is 90, but you can always put it in your calculator. So we now have found Anne's distance. Okay, so now what about Beth's distance? So let me write this little BD here. BD for Beth's distance. So Beth, her rate is 55. So we have 55 miles per hour for Beth. And again, the time is going to be the same. So again, we're just using this formula here. Distance equals rate times time, where BD is Beth's distance. Beth's rate is 55, and the time is 2 hours. So we do 55 times 2. What is 55 times 2? 55 times 2 is 110. And these are miles. So we know that Anne drove 90 miles and Beth drove 110 miles. So let me just bring this triangle here so that we can see this a little bit better. All right, so this is the 90-mile side of the triangle. All right, so this side of the triangle is 90 miles. And so this side of the triangle here is 110 miles. So we can say that the side A of our triangle is 90 miles, and side B of the triangle is 110 miles. So in our formula, A squared plus B squared equals C squared, okay, we can find side C using this formula. So let's take 90 squared. So we want to do 90 squared plus 110 squared. And this is going to be equal to C squared. And again, C is the distance between them, right? How far apart they are is C. All right, so 90 squared plus 110 squared. So do 90 squared in your calculator. That's 90 times 90. That gives you 8,100. So we have 8,100 plus 110 squared. So 110 squared gives us 12,100. All right, and this is equal to C squared. And so if we add this up here, that gives us our C squared. So we'll find that 20,200 is equal to c squared. So is this the correct answer, yes or no? The answer is no. So we found c squared, but we want to find c. So when you've got a scenario like this where you've got 20,200 equals c squared, you just want to get c. So what we have to do is we've got to take the square root of both sides of our equation. So we're going to take the square root of both sides. So we've got to take the square root of c squared, which will give us c, and we've got to take the square root of this big number, 20,200. And so hopefully you've got all the stuff in your notes here. If not, you can rewind the video or pause it now, but I'm going to clear some space out of here. So we cleared some space out, and so we've got 20,200 is equal to c squared, and so what we do is we take the square root of that 20,200, and the answer is about 142.13 miles. And that's equal to side C. So the answer, again, about 142.13 miles apart. And so this is side C of our triangle here. All right, so just a quick recap, what we did was we knew that Ann was driving west, and we knew that Beth was driving south, and we knew the times for both of them, 2 hours. We knew both of their rates, so we were able to find the distance that Ann traveled using the distance formula, and we found the distance that Beth traveled using the distance formula. And so we knew that because we had a 90-degree triangle, we could use the formula a squared plus b squared equals c squared, the Pythagorean theorem. And so we did the math here. We did 90 squared plus 110 squared. And the answer that we got for that step was 20,200, which equaled c squared. But that's not the final answer. So we had to take the square root of 2,200, which gave us about 142.13 miles, which is our answer. Question 5. In a high school math class, the class average on the last test was 79. The teacher gave 2 students an extra 3 points each, added to their test scores. This increased the class average to 80. How many students took the test? So pause the video and try to solve this question now. All right, let's go over this. So first of all, how do you find the average? Well, the average in any question really, to find the average, what you do is you want to take the sum of all the numbers in some kind of data set, right? And so let me write the symbol for sum here. So this is what the symbol for sum looks like. It looks kind of like an E, all right? So you take the sum of some kind of values in a data set. So in this case, all of the values in the data set are going to be test scores. So here we have the sum of the scores. So if you were going to find the average, you would have to add up all of the test scores, and you would then divide by the total number of numbers in the data set. So in this case, since each student took one test, the total number of numbers here would just be the number of students or the number of test takers, right? So we've got the number of students or test takers, all right? So the average is the sum of all of the scores. And again, that's what that little symbol that kind of looks like a capital E means. And so we would take the sum of the scores, divide that by the total number of students. All right, so again, the average is the sum of all the numbers in the data set divided by the total number of numbers in that data set. In this case, the sum of the scores divided by the number of students would be the average, which we're given 2 values for the average. So let's break this down. So in the first, let's write 2 equations here. So the first equation, which we can write here, would be 79, right? The average was 79. And that's equal to what? So the sum of the student scores. So again, this little E symbol here represents the sum. So all of the scores would get added together. So we would have the sum of the scores divided by what? The number of students. And so now let's just write X instead of writing out number of students. Let's just put an X. So the first equation is 1. 79 is equal to the sum of the scores divided by X. But we can also write a second equation. So the second equation that we can write is based off of the additional information in the question here, which tells us that the teacher gave 2 students an extra 3 points each, and that this bumped the average up to an 80 here. All right, and so again, what we're trying to do here is find how many students actually took the test here, which would be our X. So how many students took the test? that is what x represents here. So x is the number of students. So the second equation is going to be, let's take the average, which is 80 this time. That's equal to what? Well, the sum of the scores is going to be the same. So we've got the sum of the scores, and this time I'm just going to write an S for scores. So we've got the sum of the scores, but this time we're adding what? We're adding 6, right? Because 2 of the students gets an extra 3 points each. 2 times 3 is 6. So we have the sum of the scores, which is the same as in the first equation. However, we also have to add another 6 points this time to the sum of those original scores. And the reason again is because there are 2 students that get an extra 3 points the second time. All right, or the second in the second equation here, because remember the first equation, the class average was just 79, so the teacher gives 2 students an extra 3 points. So we're writing a second equation based off of that new information. So the average in the second case was 80. The sum of the scores is going to be the same, but we're adding 6 again because there's 2 students and they each get 3 points. So hopefully that's clear. And the number of students is not going to change. All right, so we now have 2 equations. We've got 79 equals the sum of the scores divided by x, and we have 80 equals the sum of the scores plus 6 divided by x. So again, we're trying to solve for x, so we've got 2 variables here. So one variable is our x, which is what we're trying to solve for, and the second variable is the sum of those scores. So we don't know what the sum of the scores is, and we don't know what that x is. But the variable that we want to get is x. So we've got 2 equations here, and what we want to do is solve one of them for the sum of the scores. And the reason that we want to solve for the sum of the scores is because, say we take 2, solve it for the sum of the scores, and we then take that sum of the scores and we plug that into equation 1, and that's going to help us solve for x. Okay, so let's take equation 2 right here, and let's solve it for the sum of the scores. So we want to get this sum s by itself. So we've got sum of the scores plus 6 divided by x. So we can multiply by x on both sides of this equation. And again, we're taking equation 2 and we're going to solve it for the sum of the scores. And by solve it, I just mean we want to get sum of the scores by itself on the right-hand side of the equation. And so we're multiplying by x on both sides. So we multiply by x on both sides. We end up rewriting equation 2. So I'm going to draw this big arrow here to show that I'm rewriting equation 2 now. So we have 80x, and that is equal to the sum of those scores plus 6. So now all we have to do to get that sum of the scores by itself is subtract 6 from both sides. So we subtract 6 on both sides of the equation, because whatever you do to one side, you have to do to the other. So we're subtracting 6 from both sides of the equation. So hopefully you got that in your notes if you wanted to, because I'm going to clear that subtract by 6 out so we have more room to work here. But hopefully you remember that. And so we would have 80, or left with 80x minus 6 is equal to the sum of the scores. And so now that we've got the sum of the scores in equation 2, so this whole thing again, we've rearranged equation 2 to solve for the sum of the scores. So the sum of the scores is equal to 80x minus 6. So we now take this 80x minus 6 and we go back to equation 1 and we want to substitute this 80x minus 6 into the equation for the sum of the scores. So let's take this equation here and we have 79. So we're now taking equation 1. We solved equation 2 for the sum of the scores, and we found that the sum of the scores is equal to 80x minus 6. So we're now going to substitute this 80x minus 6 in here for the sum of the scores. So 79 is equal to 80x minus 6. And so this is all over x. And so this is all over x. So now what we can do is multiply by x on both sides of the equation here. All right, so let's do that, and we would get 70x is equal to 80x minus 6. And so we want to get x, we're solving the equation for x, so we want to get x by itself on one side of the equation. So we've got 79x equals 80x minus 6. So now what we can do is we can subtract 80x from both sides of the equation here. So we want to get the x by itself on one side of the equation. So we're going to do 79x minus 80x. And since we're doing 79 minus 80, we end up with negative x equals negative 6. So we can divide by negative 1 here, right? So we can drop the negatives from both sides of our equation. We're just left with x equals 6 here. All right, so if we divide negative x by negative 1 and we divide negative 6 by negative 1, we'd just be left with x equals 6. So the answer here is x equals 6. So we found that there were 6 students in the class. And so again, all we did was we just wrote these two equations out based off of the information that we were given here. And so then we picked equation 2, we solved it for one of the variables here. So there were two variables, there was the sum of the scores, and there was x. So since we wanted to find the sum of the scores, so we solved this equation for the other we wanted to find x. So ultimately we were trying to solve for x. Okay, but in order to do that, we took equation 2, we solved it for the sum of the scores. And then once we solved it for the sum of the scores, we plugged that sum of the scores into equation 1. And the reason that we solved equation 2 for the sum of the scores was so that we could plug that sum of the scores into equation 1 and we'd be working with just one variable. So that one variable that we ended up working with was the x, which was ultimately what we wanted to solve for, and we got x as our answer as 6. So x equals 6, meaning 6 students in the class that took the test. Congratulations for making it to the end of the video. Your next step is to make sure you've seen my first GED math practice quiz and also check out my second GED math practice quiz, and then you'll be on your way to passing in no time. Thanks for watching.